Hello. Hi,
Yes, sir.
guys. Okay,
Yes,
okay.
sir.
Is there any noise in my from my voice? Is it good, right?
Voice is coming background.
There is a noise is coming.
Yes, sir.
Noise or voice? Oh, voice. Okay, okay. Okay, guys. Is my screen is visible for you?
Yes, sir.
Okay, let's wait for others for 5 minutes or 2 minutes. Why not? Okay, guys. Okay, guys means when I am teaching, not here. This is the beginning. That's why I said hello, guys. Why not 175? Okay. It's a PBH. Who is PBH? Oh, okay, Bhagya Harshit. Okay. Okay, we will wait for calls also for 2 minutes. Why, Prajwal? Wait, we'll wait for 2 minutes. Otherwise, we'll start the class. So, today is the last concept and last applications in Coulomb's law. Okay, so there are four applications are there. We'll complete those four applications, and tomorrow we are going to discuss. I will give you the DPP, at least two, at least two DPPs I will give definitely, and I am preparing for third DPP also. If possible, I will give. Otherwise I will give you the two only. Just understand that. Okay, just understand. Okay. So yeah, guys. Today concept is very important, and this concept we are going to use in electric field. Okay, electric fields, it will not take this much of time. It will take only 3-4 lectures. Then we will move into the electropotential. I understand because now whatever we learn in electric force, or that means Coulomb's law, whatever we learn the applications, methods, everything, it is similar. The same applications we are going to apply in the electrostatics. But in electrostatics, what is the Bhagya MC? Okay, in electrostatics, so we are going to deal with the applications: line conductor, circular conductor, ring, okay, sphere, all those things. Cylinder, solid cylinder, hollow sphere, solid hollow sphere, and we will take that length conductor also. And some applications we are going to discuss about square of the box and plate, lamina sheet, all those things. And these are the applications we are going to discuss. There is nothing new we are going to discuss in the electric field, because we already know the electric force. That's why we don't need to discuss more in the electric field. The methods we are going to apply. Okay, let's begin the class today. No need to wait for. Okay, hello guys, welcome to the class today. And yeah, last class I given, yeah, Bhagya Harshit, I given the black background for you. And last class I explained this formula: x divided by x square a square 3 by 2 dx. which is equals to minus 1 over x square plus a square 1 by 2. So second equation what I given, if there is no x here, okay, in the first equation we have x, in the second equation we don't have x. A square 3 by 2 dx which is equals to, ఇక్కడ x లేదు కాబట్టి ఇటు సైడ్ x వస్తుంది, x divided by a square into x square plus a square 1 by 2. So these two applications are very important, guys. Okay, so in electric fields we are going to solve this we are going to solve the application. These two formulas will come. How it will come, we will see that today. Let's continue the discussion. Continuous charge distribution. So last class we are continuing continuous charge distribution. So here I am going to discuss the two cases. Case 1 and second one is case 2. Okay, please wait. In the case 1 I am taking two diagrams like this. Okay, so this is my line conductor. In the second case, I am taking another line conductor like this. Okay, this is a half circle and another line conductor. So our duty is we have to find electric field or electric force at this point. And here we have to find the electric field or electric force at this point. If you observe carefully, this point is exactly at the center of this conductor, line conductor. And this point is also, if you consider, it is the center of this conductor. And I am taking another case. Oh, okay, okay. Okay, okay, Gandhi. Please wait. I am changing the earphones. 1 minute. Okay, is it okay right now? Please respond. Oh, I didn't explain some sphere charge distribution. Okay, okay. I will explain. Don't worry. I will explain. Don't worry. And formula 2. Okay, is my voice is clear right now, right? There is no noise, right? First. Okay. Then come to that. No, no, Toyajax. Formula 2 is not wrong. This one. This is formula 1, formula 2. No? So 1 over x square plus a square whole power 3 by 2 dx, which is equals to x by a square into x square plus a square 1 by 2. Formula is correct. I told another. Oh, what I given yesterday? Oh, I given these formulas only, na? Okay, please note it. If I give in another formulas, okay, please note these formulas. These are correct formulas. Okay, let's continue the class. And in the second case, I am taking In the second case, I am taking like this. You didn't wrote a square, sir, in the denominator in formula. Okay, okay, okay. Okay, so here I didn't wrote. Okay, guys, that's my mistake. Please correct it. There is a square here. So 1 hour. So if there is a x, it will come minus, there is no x, 1 over x square plus a square power 1 by 2. If there is no x, so x by a square into x square plus a square. Okay, please correct it. It's my mistake. Thank you, guys. Okay, okay, let's continue the class. Now take, I am taking the same line conductor. I am taking the same line conductor. Okay, and again here also I am taking, now I am taking here in terms of this, and just take, so here I am taking my conductor like this. This is my conductor. So in this case, please carefully observe. In this case, I wanted to find the force at the center of the conductor. Okay, it's equal. Here also I wanted to find at the center. But here I wanted to find the my force or field at the corner. Here also I am finding at this point. Okay, if carefully observe, from this point, this whole distribution, okay, so this is a charge and linear density. So there is a charge and there is a linear density. So if you observe from this point, my charge is distributed equally from the center. So that's why here we are calling it is a symmetric distribution. Got it? This is symmetric distribution. Here I wanted to find my force. Here I wanted to find my force. Here also I wanted to find my, I will take q. Okay, okay, I will take small q. I wanted to find my force. Just take this point q. This is the source charge. And here I wanted to find net force on q something. Here also I wanted to find net force, but this is not at the center. This is somewhere else at the corner or whatever it is. So this is unsymmetric distribution. Unsymmetric distribution. Don't think that, sir, so the charges are distributed on this equally, then why you're saying unsymmetric? No, no, no. Here I wanted to find that my charge at the corner. Okay, that's why I'm saying that it is like unsymmetric distribution with respect to q. Here my charges are distributed equally from the center. So that's why I'm saying that this is the equal distribution. Okay, don't confuse it here. Okay, sir, then how to find this? There are some method to find this answer. This method is important and we are going to discuss now. So first, what you have to take? First, we have to take two elementary, got it? Two elementary lengths on both sides with equal distance. With equal distances. Okay. Second thing is what we have to do. We have to find the, how to and add. We have to resolve that vectors and add. So third one is very important. We have to take half limits only. Half limits. So half limits means if I take this my line conductor, so my limits are 0 to L actually. Yes. So in this case, I have to take the half limits only. Got it, guys? Prajwal? Why, sir? So what, why, Prajwal? And which question you are asking, why? First one. Acha, why method? No, actually there are different methods. Okay, so here I am taking, if you take this method, you can easily get the answer. Some people will take that, they will resolve the vector, and they will sometimes they will differentiate, and they will take the full limits also. But here I am giving to get the answer easily, so that's why I am giving this method. So got it? So this is not a mathematically proven, so this is the method how to solve the problem. Got it, guys? And and in this method and in this method, what I have to take? So here we have to take only one elementary length. We'll take the example, don't worry, elementary length. And so we have to resolve on ఒక elementary length కనుక్కున్నప్పుడు we have to resolve, and we have to find df of x and df of y. So from this we can find that my fx, from this I can find my fy. So in this case we have to take the full limits. Okay, Nandi, take the full limits. I will see the comments. Okay, no comments, it's fine. You have to take the full limits. Are you understand, right? Let's take the example. Let's take this, solve the first problem. Is it understand? This is the method only how to solve the problem. We are not dive into the problem directly. Now let's take the first case, first problem. I am taking, this is my line conductor. Okay, I wanted to find, I am taking, this is my charge q, and if the charge q, so there is a linear charge density lambda, and I wanted to find my, this is the source charge q. I wanted to find here what is my net force at this point. So how to find this? So we already know, I already told, we have to take the two elementary charges from the center. So if I take, this is my center of this charge, just take it, this is as a z. I am taking, just take two elementary charges like this, and this is the two elementary charges. Okay, sorry, two elementary lengths. So what is this length? This length is dx. So this length is also dx, because elementary length. And what is the charge? It's a dq. And what is the charge? This is also dq. Can you please tell what is the length, what is the distance from here? If I take distance, my distance is x. So this side is also x. Have you understand this? Now apply the same thing. Just apply. So మన కూలుమ్స్ లాలో ఎక్కడైతే మన పాయింట్ చార్జెస్ ని తీసుకొని, ఓకేనా, ట్రయాంగిల్ లో we take the 3 point charges, then we find the net force at this point. So if you observe here, q is the point charge and dx become as a point charge, and ikkada dx also is become as a point charge. So now you have to apply. So this is the plus, this is the plus, this is the plus, and my force at this point is like this, ripple, right? This is infinitesimally small. Okay, Nandi, this is not f, this is f df. And also if I take like this, so this is also df. I already told we have to take the theta value always at the this charge, source charge, then this is going to be theta, and this is also going to be theta. Resolve the vector. So second point in the resolve the vector, I am resolving the vectors. So this is the theta, I am resolving the vector, and this is also theta. Okay, now see, so this is the theta we know already. So this is df cos theta, and this is df cos theta. So this is df sin theta, and this is df sin theta. Now find the, now find, see, so this df sin theta, this df sin theta is going to be cancelled. So my force, net force in df is equals to 2 times df, 2 times df cos theta. Just to see what is this f, is it x direction or y direction? So my df is in vertical direction, that's why this is dfy. So is there any confusion, guys, till now? Oh, sorry, I didn't see that. Sorry. Why, sir? First, Prajwal. Horizontal, yes, Gandhi. Horizontal will cancel. Okay, Toya Jax, thank you. Gandhi, why? Please, can you tell me that why? Yeah, J cap. So, yes, J cap means when you are doing the problem, you no need to take the vectors right now. We will take the vectors at the end. I already discussed in the beginning class also. We solve the problem, then see that and which direction we are getting the answer, then we have to take the y and z, or sorry, y and x in the respective directions. Okay, that's why initially I am not taking. So j cap fy. Yeah, yes sir, yes Gandhi, fy. Okay, now I need the full charge, sorry, the full force, me total force. What I am doing here, I am making integral, so that's why I got fy. So I told what I have to take, we have to take the lengths from half limits. So this is my 0 to L. Got it? So what are my half limits? If I take this 0 to L by 2. So that's why I'm taking half limits 0 to L by 2. This is the method we have to solve the problem. Okay, guys. Wait, I will see that. That y direction. Yes, Kandi. So y direction. Can you please type what is your doubt? I'm unable to. J cap, yeah, y fy, that y direction. Yes, 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 that's the y direction. Okay, no, still we didn't solve the problem. Okay, na guys, we didn't solve the problem. Still, we are looking at the how to solve the problem. That's it. Okay, we'll solve the problem. Don't worry. So second example. Take the second example. What is the second example? So I am taking a half circle, half ring. Okay, so this is the half ring, half ring. So this is my source charge. What is the source charge? I am taking here Q. What I need to find? I need to find net force at this point. So now see what I said. Oh, this is, we already know. This is the radius R. What I said, you have to take two elementary charges. Okay, Nandi. This is the one elementary charge, and take this is also another elementary charge. Remove this. This is R, elementary charge. Now see what is this? This is dx. Yes, this is also dx. Okay, and this is dq. This is also dq. Is this clear? And it is showing like a, how it is showing, like it is showing like a rectangle, sorry, triangle, right? Triangle. This is the charge, this is the charge, this is the charge. Let's apply the forces. This is the plus charge, and this is the plus charge, this is the also plus charge. Plus plus will repel each other. Okay, this is the df, and this is also repel each other, and this is also df. Now what I have to do, we have to split the components, right? What you have to do, we have to split the components and see this is the theta and this is also theta. If this is theta and this is my theta, and also I'm resolving the components, guys, this is the theta. So what is this is going to be? This is going to be df cos theta and this is df sin theta. This is df cos theta and this is df sin theta. So now we can see easily these components are get cancelled. And what is my net force? My force, so my force is equals to 2 df sin theta. Okay, so what is direction? This is the y direction. So don't think that is the minus or plus. Don't take minus or plus. This minus or plus will come at the when you're taking the direction vector. Okay, now if it is down direction, we have to take the minus y or minus j cap. Okay, now this is the upward direction, that's why we have to take y cap or j cap. Okay, Nandi, don't worry, when you solving the problem I will explain this. So I need integration, that's why integration, this is my fy. So what are the limits? So if you take these limits, usually this is a half circle like this, so that's why my theta is 0 to pi. If 0 to pi, what are my half limits? 0 to pi by 2. Is this clear? I will see the chart box, please. Actually, I am explaining in different window, na? So that's why I am unable to look at your chart box. My previous message, yes. Yeah. Is there any doubts? Oh, okay, thank you, Gandhi. So why are you taking half limits, sir? See, actually, Harshit, we can take the full limits also. Okay, so if I take in the symmetric case, if I take only one direction, means one elementary, if I wanted to solve it, I can take the full limits. So if you take the full limits, this problem is going to be get a little bit difficult. So that's why in symmetric case, I am taking two elementary charges. So when I'm taking the two elementary charges by method, I am taking here half limits. In the unsymmetric, I am taking, if I unsymmetric, I cannot take the two elementary charges. I can take only one elementary charges. There I am taking the whole. Why are you taking half limits, sir? There we can take the full limits. So why here I am taking half limits? See, so is it my cursor is visible, guys? So here, from here to here, this is my elementary charge. Okay, and this is also same elementary charge. So both are same elementary charges. So that's why I need to take full elements, full limits. That's why I'm taking only half limits this side. My charge is distributing from varying from this side to this side, because my in this case my charge is distributed equally, symmetric. But if you come previous first question, unsymmetric case, wait, okay, not this. In this case, if you come in this case, if I take my any elementary charges from here, okay, my elementary charge from here to it will vary from here to up to here. Okay, Nandi? So I can find my force at this point, or I can find my force at this point, or I can find my force at this point. Like this, in each and every point, I can able to find it. That's why here my charge, my elementary distance or elementary length is changing from here to here. That's why here I am taking full length. But in this case, my charge is symmetrically distributed at this point. So that's why I am taking from this point to this point only half limits. If I find this half limits, I can able to find whole limits. Okay, now that's why I'm taking both sides are same elementary charges. If I take any elementary charges, so it will give you the this side answer, this side answer. But in this case, it is not possible. I'm taking only elementary charges. It will move whole length like this. It will move whole length like this. Is that clear? Okay, now let's solve the problem. Let's solve the problem. So are you multiplying half limits or two half limits? No, 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 Toyajax. So I will give you the example. So when you're solving the Newtonian mechanics, okay, Nande? When you're solving the Newtonian mechanics, if I take, so, okay, in Newtonian mechanics, if there is a pendulum, so there are two pendulums. If I wanted to solve this, okay, this is the mass, this is the mass, this is the tension, this is the theta. If I wanted to solve this, so I am not taking both, okay, na, I am not taking both masses here. If I take only one mass, if I take this distance, I can be able to solve this question. The similarly, here also I am taking the same method. Got it? Here also I am saving the same method. So what happened, Harshit? Why are sad? You didn't understand this concept? Is it clear or not? Please respond. Come on, Toya. Okay, okay. Okay. I hope you understand this. I didn't get any message. Now, take example. Just take one example. Consider a thin rod. Okay, Nandi. Consider a thin rod of length L, and the charge capital Q, a point charge is kept at a distance d from one end, okay, one end of the rod. So find the Coulombic force between them. Okay, so carefully observe the problem. Here they are given. Here they are given. So one line conductor like this. They are given one line conductor, and so the length of the conductor. So this is the length of the conductor. How much they are given? The length of the conductor is L. Okay, and so the charge on this Q, and we know the charge distribution lambda is there. And he told that a point charge is kept at a distance from the one end of the right. Me istam. A point charge is kept at the distance d from one end of the rod. You can take it. Either you can take right side, either you can left side. It's up to your decision. Okay, the answer will be same. And find the Coulombic force between them. See, initially what we solved that if there is a point charge and there is another point charge, okay, and they kept the some another source charge somewhere here. We asked to find that what is the net force here. Okay, and this is we solved previously. The same question here given, instead of the point charges, what is given is giving rod here. I understand the same. So what you have to take here now, consider, take any elementary length on this rod. I am taking one elementary length, this. So I know, so this elementary length is dx, and elementary charge is dq. See, this is the charge and this is the charge. And what is this distance? So this distance I am taking as a x. This distance is x, and this distance is d. Hope you understand. Now let's, what is my df? Force. My df is equals to k into, what is this? My this charge, sorry, this is not a small q, this is the big q. This is the dq. So dq into small q divided by, what is this? Total distance x plus d square. Otherwise, you can take this total distance. This total distance from this point is x. This is the x square for simplicity. Is this understandable, guys? Okay. Now, see, what is dq in charge density, in linear charge density? In linear charge density, dq is equals to lambda into dx. Substitute that. So my df is equals to k times q lambda into dx divided by x square. Is this understand? Now we need to find the total force. What is my total force? Integration of df is equals to integration of k times q lambda dx divided by x square. Now we have to take the limits. Okay, so there is a two ways of taking the limits here. Okay, I am taking here for simplicity. Either you can say that my distance x is from this point up to here. Got it? From this point up to here. So usually my charge dq may can be here, may can be here, may can be here. It will move this side. It will move this side. Means it will be move all my rod. So that's why I have to take the limits of the rod from here to, I have to take the from here. So what is the this distance? So this distance is nothing but from here. This is the distance is nothing but d. Got it? From here, what is this? This is nothing but how much this is total? D plus L. D plus L. Okay, this is d. My total length is d plus L. These are my limits. So there is another way of taking the limits. Okay, you try that. I will give you the hint. You try that method also. If you need, you try that method. I will give you. Now let's take my k is constant, q is constant, lambda is constant, and what I will get? D by d plus L 1 over x square into dx. Okay, you know how to solve, how to integral this. You know how to integral this. I am taking, wait, I am taking this here, next page, the next page. Okay, so this will become k q lambda minus 1 by x with limits d plus L into d. So just just see when, so inside there is a minus, so you don't need to substitute the upper limit first, substitute the lower limit. You will get the directly answer. So lower limit minus of upper limit. Usually how you can substitute upper limit minus lower limit, because minus undi kabatti you can substitute lower limit and upper limit. So then do LCM. What you will get? If you do LCM, d times d plus L, I will get d plus L minus t. So my answer is going to be this one, k times, so this is a q lambda and L divided by, so d times d plus L. I understand this one, this last step. We just integration after this. Is it clear? Okay. Okay, okay. Oh, yeah, good. Shocked, sir. Why shocked, Prajwal? Why BHP? Why BH? What BHP? Viral web. Oh my god. Not understanding starting. So from the which Prajwal, which one? So where you didn't understand? From the starting means from the beginning. Why no half limits? Ha, why no? This is not symmetric. So this example is not symmetric. This example is unsymmetric. That's why here we didn't take the half limits. Bhagya, Harshit. Oh, okay. Okay. BHP, Bhagya, Harshit. Okay, guys. Okay, let's now take the few previous applications right now. So let's take the application case to third application. The same I am taking rod. Okay, guys, we'll complete this concept now. So, so this is my length rod. Someone is raising hand, please. Is there any doubt? Please raise. No. Okay. So now I wanted to find the third application here. So let's take. I wanted to. I am. This is my charge queue. Acha, goals. Please, can please ask any doubts, goals? Oh, what is happening in? It's a PHB. What is happening there? Oh my God, there is a cloud. Okay, let's see. So now state this is the third application, right? So this is our so unsymmetric case I am taking. Let's take, so this distance is Z, and what should I take? I have to take any elementary charge, guys. Okay, Nandi? Any elementary charge. Yeah, PDF. Oh yeah, definitely, Gandhi. I will share you. So what is this? And this is my dx, and elementary charge is dq. Okay, and here I'm taking capital Q, that's why Q. So this is Q and lambda. So let's apply Coulombic force. Let's apply the Coulombic force. So this is the plus and this is the plus. Okay, Nandi? So this is my df and this is my theta. So that's why. So this is going to be df cos theta, and this is going to be df sin theta. So I already told. So in this case, we will not get the result. So we will get the result, but we have to find it. What is my dfx is equals to df sin theta, and what is my dfy is equals to df cos theta. Okay, we know how to write df, and we also know how to write the sin theta, right? Because they didn't give you the any theta value, we already know. If I wanted the total fx, if I wanted total y, I have to integrate this. So what are the limits? So limits are from 0 to l. So 0 to l, 0 to l. Is this clear, guys? Is this clear? Yeah, I will send you definitely. And I am giving you now I will explain one problem also, and I will suggest you, and please take this as a homework. Take this fourth one as a homework. Take this fourth one as a homework, and take x-axis, and I will see. Wait, I will see the chart box. 1 minute. And this is my quarter ring. Okay, please find what is the force at this point. Okay, no need to show, just give me that what is my fx, like this, like this, no need to derive what is my fy, and give me the what are the limits, what are the limits here. Okay Nandi, so just take this is my r. Okay, yes. Yeah, Tejax, I already told you in the beginning of the class. Tomorrow we are going to solve the problems. I will give you the two DPPs minimum. I am making third DPP also. If possible, I will provide three. And Monday you have exam test also. Okay, na? I am saying, please prepare the notes, class notes, and solve the problems from the given material, because the test is not going to be simple. Okay, it's going to be difficult only. It's like a standard of NEET and standard of JEE. Definitely, I'm saying it. Okay, let's take the another example, the same example, and I am taking that. Now we are solving the examples. So they are given line charge line charge, okay, line conductor. Okay, I wanted to find that. So what is my force at this point? So I already told. So this is the q and this is the lambda. So we find this is my distance of z, and I just take somewhere. So this is the dx and this is the dq. Somewhere elementary charges, the dx and this is dq. So we already solved this, no need to worry. I'm resolving this vector. So this is my df and this is my df. So I no need to do, you already know this. What you got the result at the end, I'm writing the result directly. Okay, so what I got the result from the previous, my dfy is equals to 2 times df cos theta. Okay Nandi, what is df actually? What is df? Please write what is df. See, df is nothing but k times dq. Okay, oh, this is a capital Q, dq, dq is also dq. So dq and small q divided by, so this distance is x, x square plus z square root of, and this is whole square, that's why x square plus z square. And what is, okay, this is, now substitute here. So 2 times, what is my df? K q dq divided by x square z square. What is the cos theta? I already told, if they didn't give you the any theta value, you have to find the theta. So cos theta, this is my theta, adjacent side divided by hypotenuse, x square plus z square. It's a 1 by 2, not 2 by 2. Okay, I will see the chart box. Please let me complete this because time is running. And dfy is equals to 2 times kq. So how I can write my dq? How I can my write dq? Dq is nothing but lambda into dx. Okay, substitute these values also, and z into lambda dx divided by, so x square plus z square whole power 3 by 2. Right? Is there any doubt? Is this clear, guys? Okay. See, let me take what I want. I need my f. That's why I'm making integration. Fy is equals to, let's take all the constants, 2k q z, and lambda is also out. What I will get? Integration dx divided by x square z square whole power 3 by 2. Is this clear? Is there any doubts? Okay, so what is this formula? Now tell me what is this formula. Now tell me what is this formula. So we already explained this formula, right? We already explained this formula. 2kq z lambda into, what is this formula? Can anyone please? Oh, sorry. You're in online, na? I forget you guys. So 1 minus, minus 1 divided by x square plus a square. A square means here z square. Okay. So z square whole power 1 by 2. Okay. What are the limits here? Limits. So this is the symmetry condition. That's why I have to take the limits 0 to L by 2. So this is also 0 to L by 2. Let's substitute the values. 2kq z lambda into, substitute our first lower limit because there is a minus, that's why. So 1 divided by, if I substitute in the x, I will get z square 1 by 2 minus of, and L square by 4 plus z square 1 by 2. Okay, just resolve this. Wait, I will copy this. Wait 1 minute, guys. I will look. Why it's not copy? Yes, yes. What happened? I mean half. Uh-huh. So come on, sir. Formula 2, sir. Formula 2. Okay, okay. So let's now solve this. And 2kq z lambda. So this is nothing but 1 by z. And so how we can write this? This is 1 by L square by 4 plus z square. That's it. Okay. So this is the answer. Okay, if they given the value, you have to substitute the values. So kq zg 1 by g L square plus 4 plus z square. So this is the solution. This is the way if they given such kind of problems. Okay, so I will give you the homework. I will give you the homework. Please try to solve that one also for homework. Homework, and take so line charge density. So okay, and find the net force here. Find the net force here and give the formula in this format. Okay, Nande? Give the formula in this format, not xy components. Give the formula in this component. Yes. So root for second. Sorry, Gandhi. Yeah, yeah. Okay. Yeah, guys. Is there any doubts? So tomorrow we solve the problems. Okay, tomorrow we'll take the only problems, and please be prepared and come for tomorrow class. There are one application is there. I will explain that. Okay, guys. Bye. So your doubt is the classes understand, right? Is there any doubts? Okay, Tata. Tata. Bye bye. Khatam. Oh, okay, Daya Jaksh. Just ask me if you have any doubts. Just who is yes, KLNYX, please tell me. Acha, homework limits. Yes. See, here I wanted to find. If I wanted to find, is this my system symmetric or unsymmetric? If there is an unsymmetric, what I have to explain? What limits I have to take? Which limits I have to take? I already explained. No, 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 no. If it is unsymmetric, I have to take the full. Yes, Gandhi, correct. No, no, no. Full limits you have to take. Yeah, 0 to L. Excellent, excellent. 0 to L. Yes. And you have to use the formulas. I given the formulas 1 and 2. You have to use those formulas, then you will get the answer directly. Okay, guys. So thank you very much. So we will end the class here. Okay. Thank you. Bye bye. Time. Yeah, it's 4 minutes. No need to worry. Okay, thanks. Thank you, guys. Bye.